So what I thought we'd do is investigate today an explosive mixture of methane and air. And to do that, we're going to use this very crude device. It's just simply a can. Now, me and Neil have doctored it slightly by drilling a couple of holes. Okay, one in the bottom and one in the top. Now, what I'm going to do is I'm going to fill the can from my gas tap. So I'm going to fill it up with gas. So you can hear it filling.
Methane is actually found in our gas taps. So here in our lab, we've got a gas tap here and methane comes out of it along with some other stuff as well to actually give it the smell. Because normally methane doesn't really smell of anything.
So this is methane, carbon with 4 hydrogens around it, CH4. Methane is the simplest compound of carbon and hydrogen, and it is an enormously widespread molecule in the world.
So what we're going to do is actually use this to bubble methane gas into a soapy water solution, okay? So that's all it is, just a tub of soapy water. In it goes, tap goes on.
It is the basis of so-called natural gas, the gas that's found deep in the earth and which you can drill down and recover. It's used for heating and energy all over the world.
So let's show you the combustion of methane. So simple combustion. We're going to use a Bunsen burner. I just need to light it. So you can see the methane's burning quite nicely in the atmospheric air, and you're getting this rather nice incandescent flame.
It's also formed when plant material decomposes. So if you have a pond, a little lake, and plant material falls in and decomposes on the bottom, if you stick a stick in, bubbles of gas come up.
So all that's happening, and obviously I've got the benefit of being able to smell it as well as hear it, is that the methane gas bubbles are forming, they're soap bubbles, but instead of it being air trapped inside each bubble, every single bubble there has methane inside it.
If you collect this gas, you can actually light it with a match and it burns. And I've done that when I was younger.
And to prove it's methane and not just air that we're putting into it, I don't have match on a stick like Pete does. So that I don't burn myself, I'm going to coat myself in some soapy water and then scoop up a handful of this.
Methane is also formed when plant material decomposes inside the digestive system of an animal. It's particularly dramatic in cows, but it happens inside you or me, that this material is digested by bacteria in your digestive system. Part of the carbon in the food that you're eating is converted to methane, and you can belch it out or expel it as wind from the other end.
Okay. Now then, methane gas and alkanes in general are very energetic, like you can see with the flame. And in fact, it's similar compounds, those with a bigger, perhaps a higher molecular weight, which are used to drive things like cars, buses and planes. And they basically use combustion or an explosive combustion inside the combustion engine of a car. So you mix oxygen with the fuel, in this case we're going to use methane, in the appropriate amount such that they mix to be stoichiometrically correct, such that they explode into life and they react instantaneously and cause a big pop.
Methane, when it goes into the atmosphere, behaves like carbon dioxide because it can absorb radiation, infrared radiation, and cause global warming. And it absorbs the radiation via the vibrations of the carbon-hydrogen bonds, and the vibrations when they stretch and also when they vibrate, so-called scissors vibrations.
Now what I'm going to do is I'm going to fill the can from my gas tap. So I'm going to fill it up with gas.
Methane, in fact, absorbs radiation much more strongly than carbon dioxide in the atmosphere, but its lifetime, the molecule's life in the atmosphere, is shorter because it eventually reacts with oxygen and turns to carbon dioxide. But the methane that's emitted by intensive farming of cattle can be quite a contribution to global warming.
Okay. And then, when it's completed, I'm going to set fire to the top. So now I have a reservoir of gas inside my can, which is burning in the atmosphere. Okay? Now then, as we're using up the methane inside, something really cool is happening. Atmospheric air, including oxygen, is being sucked in through the hole in the bottom of the can. So as the methane is being used, more air is going in. So if we think about the can, the amount of methane is going down and the amount of air is going up. Eventually, they'll reach an explosive regime and something exciting might happen in the can. So we're going to walk away from it a little bit and wait. So what we're looking for now is the flame on the top. It's getting smaller and smaller and smaller as the burning methane gets less and less and less. And then hopefully that flame will pop back inside the vessel and pop! Let's see. It could take a while because these cans, they do take a while to burn out. So when the flame disappears, cover your ears. It's not going to be that bad. So, inside the can, we developed an explosive regime, or explosive concentration of methane and air, and it instantaneously reacted and blew the top off, as it made lots and lots of hot CO2 and hot water vapour.